Hello? Hello guys, if you can hear me, can you please type something in the chat? Or type something in the question answer app, which is open there. Hello guys, can you hear me? Could you please type in the chat box or in the question answer app? So we are going to discuss some problems and graded problems from week 1. Can you hear me? Okay, 1 second, I'm having some issues with this Google Hangout. Varun, I received your question in the question answer tab, but could you please put one more comment over there if you can hear me perfectly? Okay, perfect. But I don't know why I can't see you guys over there at the bottom of the screen. Anyway, I'll start. I'll start then. Okay, so I received from Paul Helly that you can hear me. Perfect. Alrighty. Okay, then we'll start everything now. All right. Give me a second. Let me screen share the questions here. 1 second. So I'll start one by one from problems because the first problem in the problem exercise was very easy. So I will not be I won't discuss that one. So initially we'll start with problems for practice, and then we'll start with graded problems. All right. So if you have your screens open with the problems, practice problems. So we'll start with uncertainty in supply chains. Okay, 1 second. Paul asked me I can hear you. Is there another panel to enter chat? Okay, 1 second. I'm having issues with Google Hangout. I think they updated the app, something. I'm extremely sorry. Give me a minute. Let me just resolve it. Hi, do you see the chat window around you? Okay, anyway, so let's start this one. Okay, so I'm gonna start with our practice problems now. So can you see the screen where I'm showing practice problems? Okay, so here we go. Our first question here says, so over here, our first question says, suppose that daily demand for bagels at the local coffee shop where you work is found to be normally distributed with a mean of 250 and a standard deviation of 75 units. And suppose you have 350 bagels ready to sell on a certain day. What is the probability that you will run out? That means in this question, we need to find probability that we will sell more than 350 bagels that day, because you have 350 bagels with you ready, already prepared. So we don't need to find probability that your demand will be met. We need to find the probability that your demand will not be met. Okay, so how to do this question is very easy. So what you have here, in the question, we're giving mean of 250 and standard deviation of 75 units. And here we are given that we have 350 bagels ready. So that means we know three things in this question. First one is mean, second one is standard deviation, and the third one is X. How many bagels do we have with us right now? From this information, what we can find easily, we can find the probability that our demand will be met. And what we need to find out is the probability that our demand will not be met. So how to do that? First, we have to convert all this information into the unit normalization table. So for that, we need to find the value of K, right? So how to do that? So I'll take you to the other screen now. Now, if you see this one, So we have mean 250, standard deviation 75 units. We have x equal to 350. So we need to find what is the probability that you will run out. So first transform it into unit normal. That means we need to find the k. So k will be x minus mean upon standard deviation. That will be 350 minus 250 upon 75. So that will be equal to 1.33, right? So from this value of 1.33k, we'll go to our unit normal table, which is given over there. So can you find out the value of k? Well, the probability using the value of k, which is 1.33. So to find that, we'll just use the table. So if you see on your table, you will be having a number of columns and a number of rows. So what you need to do is you need to see the value of k as 1.33. So if you can see here, this is the value of k on the same table. I just clip this image from the same table. So for value of k equal to 1.33, you can see the probability. If you see here, the probability is 0.9082. So with this probability 0.9082, this means that we will not run out. So we have 90.82% chances that our demand will be met. But what the question is saying, what is the probability that you will run out? That means we need to find what will be the probability that there will be more than 350 orders that day and we cannot meet the demand. So that will be 1 minus 0.9082. So here that will be 0.0918 probability of stocking out. Okay, so 9.18% of all the time we are gonna stock out, right? Is this problem clear? So if this problem is clear, could you please reply something in the question answer tab if this question clear? All right. Okay, so that's fine now. So I'm gonna discuss the question number 2. So if we go back to our edX problems, so now if you go to question number 2, it says, this is not good enough for you. How many bagels do you need to prepare to have only 5% probability of running out? So this question is very similar, but it is asking you in a different way. So we need to find how many bagels do we need if we have only 5% of probability of running out. So here they have already sort of given probability, so we have to go reverse, right? So here it says 5% probability of running out. That means if we can find the value of k when 95% probability is meeting the demand. So what it says over here is, when it says 5% probability of running out, that means 95% probability will be met, right? That means our demand will be met 95% of all the time. So now if using the same unit normal distribution, if we can see the value of k when 95% probability is meeting the demand, right? With that value of k, if we can find the value of x, then that will be the answer. So here what we have, we know k is equal to x minus mean upon standard deviation. So here we know the mean will stay the same, 250. We know the standard deviation, 75. It will stay the same. And we need to find value of x here. We need to find how many bagels we need to prepare. And as far as k is concerned, again, from unit normal distribution table, we know what k is because we can find value of k, which will be equal to 95%. So 0.95, right? So that thing, we can easily find it. So here we go back to our solutions sheet. All right, so here, if you see solution sheet, here we have mean 250, standard deviation 75 units. So 5% of running out is equal to 95% demand will be met, right? So now we need to find value of k corresponding to 95%. So we need to see the closest ones. If you see here, we have 0.9495 and the value of k is 1.64. And we have 0.9505 probability and value of k is 1.65. So what we can do here is, we can either interpolate to get exact value of 0.95, but I didn't do interpolation. You can do it if you wish to. I just took 1.65 as my k for this value 0.9505. So if we put this value of k in our equation, which is x minus 250 upon 75, and equate it to 1.65, the value of k, which we found, which is equal to 95%, right? So we can easily find the value of x. So that will be 75 times 1.65, and then add 250 to that, just to solve the equation. And you will see you need 374 bagels to meet your demand, right? So did you understand this question? It's always a good idea to print your unit normal distribution tables all the time. Okay. So these are the unit distribution tables. These are available in the website. If you click the first video, it's available over here. So what I did is, so for 95% probability, which is somewhere here, here it is. So I just actually took the screenshot over there and pasted in the Word document, which I'll share with you all after this hangout is over. So if this question is clear, please give me a good to go for the next question. Shall I move to the next one? Shall I move to question number 2.3? If you have any doubt in question number 2.2, please use the question answer wizard and let me know. If that's fine, please let me know. Shall I move ahead? I've actually forgot to turn on the showcase function of the Hangout. That's why I can't see you guys. I'm so sorry. For the next Hangout, I'll make sure I do turn that function on. I think I cannot really turn that function on now. All right, perfect. Okay, so now we'll move to our next question, which is question number 2.3, where it says you want to be even sure that you do not run out of bagels. So how many bagels do you need to prepare to have only 1% probability of running out? So when we say 1% probability of running out, what will be the probability of meeting the demand? Type your answers in the questions itself over there, because only question answer wizard is open at the moment. So what is the probability that you will run out only 1%? What is the probability that you will be meeting the demand? So what's the probability that you will be meeting the demand? Okay, so the probability of meeting the demand is 99%, right? So using the same unit normal distribution, we can find the value of k, and using the same equation, which is x minus mean upon standard deviation is equal to k, we can find the value of x. So here, when we need to find how many bagels do we need to prepare x, so that we will stock out only 1% of the time. That means 99% of the time we'll be meeting our demand. So this is really easy. Let's go back to our solution sheet. So here is it. So we already know the mean, we already know the standard deviation. We know 1% of running out is equal to 99% demand will be met. So using the unit normal distribution table, we can find the value of k corresponding to 99%, that is 0.99. So 2.33 is closest estimate to 99% that demand will be met, right? So our value of k will be 2.33. All right, and using this value of k, we will move towards finding the value of x. So here it is. So k is 2.33. We'll plug this value in our equation. X minus mean upon standard deviation is equal to k, and from there we can find the value of x, that will be equal to 425. So we need to prepare 425 bagels to ensure we are meeting 99% of the demand. And if we go back to the previous question, we needed to prepare 374 bagels to ensure 95% demand will be met. So you see the huge difference. With 374 bagels, 95% demand is met. And with 425 bagels, 99% demand is met. So that's like a big, huge difference. Now we go back to our problem set and we'll do the next question. Do you have any problem in this question? I think this is pretty straightforward. We can move to the next one, right? So if you move to the next question here, 2.4, it says, you make an interesting observation. Keeping 350 bagels ready to sell provides you with about a 90% probability of not stocking out. Increasing by 23 bagels improves the probability of not running out to 95%. However, to get just 4% higher, it takes 52 additional bagels. So why is that? Because if you see, the unit normal distribution is always a long curve at the end. It's almost going to infinity. So to approach 95%, you have to really, really improve your manufacturing units. Okay, that's why the correct answer for this will be the long tails of the unit normal distribution make it increasingly hard to improve upon the high levels of service. Because if you see the graph, it is symmetric to either side. So if you keep going right and right and right, it will never end. So to get the 99% accuracy, you have to prepare a huge number of bagels. All right. So shall we move to the next question? So our next questions are the 3-month free salary stores. So before I do this one, we'll try to solve percent distribution cakes at Bagels shop. So this question involves percent distribution tables, and then you will get a good view of how to solve these questions too, right? So please give me a head start if you're fine with this question 5.1. Paul, Varun, Gabriel. So shall I start with the next question? 5.1. You can type your comments in the question answer app, which is open. Hello? Hello, can you guys hear me? Hello, can you hear me? And anyway, I'll start with question number 5.1. So what question number 5.1 says? What is the probability that you will sell more than 3 cakes in a week? So at the bagel shop, you have some cakes that are pretty slow movers. The chocolate cake, for example, only sells an average 2.5 cakes per week. You have noticed that the demand follows a Poisson distribution. So here, this average 2.5 cakes per week will be your lambda. So lambda is 2.5 cakes per week. So we need to find the probability that you will be selling more than 3 cakes in a week. So if you want to sell more than 3 cakes in a week, what is saying here is we need to find the probability first that your demand is meeting, that you're able to sell 3 cakes in a week. And then we can see 1 minus probability will be the probability that you will sell more than 3 cakes in a week. So here again, we'll be using our Poisson distribution tables, right? So let's go back to our solution checklist. Okay, so here, what we are given here, we are given lambda 2.5. So if you see your Poisson distribution table, so for lambda equal to 2.5, and we first, what are we going to do is first we are going to find the probability of that our demand will be meeting with the production of 3 cakes or selling 3 cakes, right? So we need to find the probability that we will sell 3 or less than 3 cakes. So that can be easily found out from Poisson distribution tables. If you see here, if you put your finger to 2.5 lambda, if you come down to level 3 here, you will see the value of probability is 0.75758, right? So with this value in hand, we can use the probability. So the probability of selling equal to or less than 3 is equal to 0.75758. So this is the probability that you will sell equal to or less than 3 cakes, okay, in a week. But we need to find the probability that we'll be selling more than 3 cakes in a week. So that will be 1 minus 0.75758. That will be 0.24242. That's approximately 24% times that you will be stocking out. Okay? So 4%, 24% times you'll be stocking out. So let's move ahead to the next question, and I'll just take you quickly through these questions so that we can go to graded assignments. So here we have next question. It says, what is the probability that you will sell no cakes in a week? 0 cake in a week. So this is again very simple because we already know what lambda is. Lambda is 2.5. Well, lambda equal to 2.5, and then we see f of x equal to 0. That means no cakes in a week. So that's very easy to find out too. So what we're going to do for that, again, you'll use your distribution table, Poisson distribution tables. And then you can see here that when lambda equal to 2.5 and probability and no cakes, 0 cakes in a week, you will see the probability will be 0.08208. So probability of selling 0 cakes is 0.08. That's almost 8% of the time you will sell 0 cakes. Okay? I hope this is pretty straightforward here. You don't need to subtract this probability because they're not asking what's the probability of selling more than 0 cakes in a week, right? So that's pretty straightforward here. And now we'll do this one, 5.3. Suppose you have 5 cakes made ready to sell. What is the probability that you will sell out? Okay, what sell out means here? This is those tricky questions. This is one of the tricky questions here. Many students got it wrong. So what we have to do it here is, so here it says, oh sorry, I didn't put that on. Here it is. Here's a problem. So what this problem says, suppose you have 5 cakes made ready to sell. What is the probability that you will sell out? So here, this is one of the tricky questions. So what you have to do here is you have to think a bit more about this one. So see here, and see in this way, we have 5 cakes ready in the shop. And what's the probability that you will sell out? Sell out means you don't have any other cake after that one. So after 4 cakes, we are almost selling out. So we need to find the probability that the demand will go beyond 4, right? So in this case, first we're going to find probability of less than or equal to 4 cakes, and then we're going to subtract that probability from 1 to find the probability that we will sell out, right? So for this one, we'll go back again to our solutions. So here if you see, I have taken the screenshot of the same table, Poisson distribution here. So with lambda of 2.5 and value of x as 4, we have 0.89118, right? The probability of selling less than or equal to 4 is 0.89118 because at 5, we are selling out. So probability of selling out or selling more than 5 is equal to 1 minus 0.89118. That would be 0.10882. So that means almost 11% of the time we are selling out if we have 5 cakes ready to sell. Fine. Do you have any problems so far? Shall I move to the next part? Shall I move to the next part? Do you want me to discuss the remaining 2 practice problems, or do you want me to jump to the graded problems? You can just type over there in the question answer app. Do you want me to discuss graded assignments now, or you want me to go to question number 3 and 4? If you guys can hear me, please let me know if shall I discuss the next grade set problems now. Alrighty, let's do this one then. So here we say, it's a huge question. So the basically what it says is, there's a company located in Spain, and they are one of the largest automobile manufacturing plants. So was there is, however, a recent graduate is hired. So they have to do ABC analysis, okay, of 50 spare parts for the company. So let's do this question one by one. So what they're asking, which SKU has the highest average weekly cost? Which SKU, which stock keeping unit? So they have given this Excel spreadsheet which you can download, and I'm gonna download this in front of you, and we'll be solving this question together. Okay, so I'll just show you that Excel sheet. Okay, I'll show you the Excel sheet now. So I want you guys to keep the copy of question in front of you, because it's a bit difficult to keep switching to the problem and the Excel sheet. So I hope you have the copy of problems with you. So our first question is, which stock keeping unit has the highest average weekly cost? Okay, so we need to find the weekly cost first. So how to do this? This is pretty straightforward. So we need to find weekly cost. So what we're going to do is we're going to make a tab for this. So weekly cost will be equal to average weekly sales times unit cost, right? So here it's very easy to write the formula for this. Just type in your cell equal to average weekly cost multiplied by unit cost. That will give you the weekly cost. And then you don't have to keep writing the formula in every cell. You can just use here on the right hand side, at the bottom part, there is a small square. You can just move your pointer to that, click and pull it down. Pull it down to all values here. Then you will see this one is your weekly cost. And now we need to find which stock keeping unit has the highest weekly cost. So to do this, just sort your function and move it in descending order. So here you see this stock keeping unit has the highest weekly cost, that is II762, right? So if you go back to our exercise here, we can see here now in the solution sheet. So which stock keeping unit has the highest average weekly cost? So highest average weekly cost will be equal to average weekly sales times unit cost. So here's the screenshot of the same thing which I did over there. So weekly cost came out to be 5,840, and that was with stock keeping unit ID II762. So that's our solution, right? So far simple. Let's move to the next question. So our next question says, which stock keeping unit has the highest average weekly revenue? So weekly revenue. So we need to find revenue. Revenue is actually the money which is flowing in the company. It is cash flow towards the company, not the cost of preparing anything. Revenue is how much you're getting, how much you're earning through selling your product. Okay, let's go back to the spreadsheet which we have. So in this spreadsheet, if you see here, so we need to find weekly revenue. again create a new tab for that, right? So weekly revenue will be again average weekly sales times unit sales price this time, right? Because you're selling the product. So revenue is actually how much money is entering your company by selling the product, how much money you're earning, in short. Again, you can copy this formula down using the small little square at the bottom right corner of the rectangle. And then again, we can use the sort function, filter it in descending order. So here we see the highest one here is 8,503, and it goes all the way down lower prices here. Revenue, so the highest revenue is given by K261 ID, right? Now I will show you this one on the answer sheet. Here is it. So which stock keeping unit has the highest average weekly revenue? So this is the one. So K261, this is very easy to find. We just need to multiply average weekly sales and unit sales price, and we got our answer, right? So now let's move to the next question. So here we have 1.3, which says, which SKU has the highest percent profit margin? So what is percent profit margin? It's simply profit divided by cost, okay? So how to do this one? Pretty straightforward. We go back to our same problem, same exercise, same sheet. So here, percent profit. So first we need to find what was the profit. So profit is equal to sale price minus unit cost, right? So unit sale price minus unit cost, that is a profit. Again, we move the profit down to all rows, and then we need to find profit margin. So profit margin is actually pretty straightforward, is equal to profit divided by cost, how much you actually put in. So here is unit cost times 100, and we're gonna scroll this down to all other values. So, and again, we're gonna sort it down in descending order. So here we have Q61. Here you can see the profit is 77.8%, because it's very clear to see here. This product is selling at 139 unit price when it was purchased at only 78 units price. And if you see it for the other unit, this unit was purchased at $60.6, was sold at $98, so there is not much increase in profit. But if you see here for this stock keeping units, Q61, the sale price is 139, where the unit price was just 78, which is pretty close to F948, but we need the highest one there in the solution, so we'll go with Q61. All right, and here you can see the solutions as well. If you need to copy it down, the profit margin is equal to sale price minus cost price upon cost price times 100. So it's the same thing we just did in the spreadsheet. So we got Q61 as our answer. All right. So Varun had problem in question 2.2. So I hope question 2.2 is clear now. Is it? Or you still have any problems? Oh, we are not doing 2.2. Sorry about that. So now we're going to do 1.4. So which SKU has the highest average weekly profit? So now we need to find average weekly profit here. So how to do this one? It's pretty straightforward. Go back to our same spreadsheet. So average weekly profit. So this is actually equal to profit times weekly revenue, right? In any way you can see that. So the better way to calculate this thing is, see here, we know the average weekly sales. And the profit which you are getting by selling Q61 is $61, assume, right? Let's assume the currency is 61, currency is dollars. So here, if you see here for this Q61, we need to find weekly profit. So we are selling 4 Q61s, we are selling 15 F948s. So here, to find the average weekly profit, it will be equal to weekly sales times profit. Or you can say another way, average weekly sales times unit sale price minus unit cost. It's the same thing. So we're gonna go with this one, average weekly sales times profit. We're gonna put this formula in all other fields. And then we're going to use our filter function to see which one gives the highest value. So if you see here, this QID K261 gives profit of 3,466, right? And if we go to our solution sheet, it will be the same. K261. So weekly profit is equal to weekly revenue minus weekly cost. It's the same thing. You don't have to worry about that. It's the same thing, average weekly sales times profit. In whatever way you do, the only thing is you have to consider profit and you have to consider how many products you have sold in the last week. Okay? And I hope this is clear so far. So do you have any problems so far? Any one of you? You can type your comments in the question and answer sheet yourself. Do you have any problems so far? Do you have any problem, or you want me to go to question number 1.5? Okay, let's go to question number 1.5 then. So which SKU has the most volatile demand in terms of coefficient of variation? The coefficient of variation is sigma upon mu, right? You all know that. So here, if we go to our solution sheet, so it is sigma upon mu, the standard deviation upon mean. Oh, sorry, I'll go back to spreadsheet. 1 second. So we need to find coefficient of variation. That is actually equal to sigma upon mu, standard deviation upon mean. So here we know standard deviation here, and we know mean. Mean is actually average weekly sales. And we're going to put this formula in all other fields, and then we need to find the highest one here. Again, we need to sort it out in descending order, and we see here L977 product has coefficient of variation 1.8. That's really very high. It's really volatile, because you can see here the weekly sales are just 4, but standard deviation is 7.23, which is really high. That's why coefficient of variation is 1.8. And if we go back to our solutions, it's the same thing here, L977. So what we need to remember in this one is, we just need to remember the formula and how to use these formulas in spreadsheets. Okay, so we just need to do C2 divided by B2, which is actually standard deviation divided by average weekly sales. Once you know the formula, the whole question becomes really easy. All right, let's go to the next one then. It's question number 1.6. So here we have two parts in this question. The first part says you want to get handle of how A items might be distributed by revenue. What percent of the total revenue is contributed by top 20% of 50 SKUs? So here, this question is a bit tricky because people were trying to do the cumulative one and they got the answer wrong. So what we have to do here is total revenue is contributed by top 20% of the 50 SKUs. So if you see top 20% of 50 SKUs, that means by revenue, first we need to find revenue, weekly revenue, average revenue, then we need to sort it down in descending order, and we need to find top 20% of 50 SKUs. That means we need to just highlight top 10 SKUs, right? And we need to find the total revenue as well. So we just divide the 20% revenue divided by full revenue times 100. That will be our answer. So let's do this one here. Let me take you to the spreadsheet. So here we have in the same spreadsheet. So we actually know the weekly revenue. We can just do descending order here. So we need to know it. We need to know the top 10 quantities here. Top 10 of, which is actually 20% of 50 is 20 upon 100 times 50. That is actually 10, right? So what we need to do here, we need to find the revenue from these fields. I'll just put it here. 20% revenue, that is equal to sum of first 10 items so here's the sum of first 10 items, and then I need to know the total revenue as well. So here we have total revenue, that will be equal to sum of all 50 stock keeping units oops, some mistake. Oh, it is SUM, not SUMN. Sorry about that. So here we have total revenue. So we need to find percentage. That will be equal to the revenue shared by top 20% of SKUs divided by total revenue made by the SKUs times 100. That will be 71%, right? So that's how we do it. So what the question is, we need to find the profit, the revenue shared by top 20% of 50 SKUs. So if you go back to our solution sheet, see the question as well, the answer. Here it is. What percent of total revenue does the top 20% of 50 SKUs contribute? So we need to find percent contribution. That will be equal to total revenue from top 20% divided by total revenue from all 50 stock keeping units times 100. So here we see, so what we do, first we do sort our weekly revenue tab in the spreadsheet in descending order so that we can see the top 10% easily. And then we select top 10%, we take the sum function, and we divide this value of sum function by the total sum of all 50 stock keeping weekly revenue, and then multiply it with 100. And there we go, we get our solution, that's 31%. All right? And now the next part of the question says, what percent of total revenue does the bottom 50% of 50 stock keeping units contribute? So it's the same way, we'll use the same spreadsheet, we'll use the same function of putting all weekly revenues in descending order, and then we take bottom 50% of 50 SKUs, 50% of 50 is 25. So we need to take bottom 25 SKUs, right? So how to do that now? We again go back to our spreadsheet, and using the same G row, G column, that is weekly revenue, we need to select only bottom 25 units. So here we go for 25 units. So you can actually use this feature in the spreadsheet count feature. It shows you how many cells you have selected, and then everything becomes fairly easy. Okay, so here we need to write for the 50%, for 50% SKUs, we need to use some function of these. Sorry, it's actually starting from this one for 577. So here we go. And then we need the total revenue, which we have already calculated before. So it will be this divided by total revenue times 100. So that's 9%. Here we have. So that's 9%. If we go back to our solutions, you'll see a very good colorful view here. So what we did, we selected bottom 25% of the SKUs. Here, these green ones, and then we took some of these 50% of 50 SKUs, and then we divided with the total revenue, and we got the percentage. So now, what this question is trying to say is, we need to see how ABC is working. If you see here in the previous question, 20% of 50 SKUs actually share 71% of the profit, 71% of the total revenue. So only 20% of the SKUs shared 71% of total revenue, whereas 50% of SKUs share only 9% of total revenue. That is the beauty of ABC classification. That means we need to pay more attention to these 20% SKUs, these top 20% SKUs, because they are actually the big earners in this organization, okay? So that's the whole idea of ABC classification. So now if we go back to practice problems, so 1.7. So here again, this is pretty much the same method here, but here instead of revenue, we are working with total profit. So we need to find the same questions, but on the profit part of the spreadsheet. Okay. So how to do this one? We again go back to our spreadsheet. So if we see here, so now we need to do it on the profit part. Let me delete these two columns to avoid confusion. So here we have the profit part, right? So we just do the same thing. We sort them in descending order so that we can see easily top 20% SKUs. That means top 10 SKUs which are sharing the maximum profit. So these are the top 10 SKUs, right? So here I can write 20% SKUs. Now we're doing for the profit. So here we go. And we need to find the total 100% SKUs profit. That will be equal to sum of all. Alright, so now for the percentage will be equal to 20% SKUs divided by all SKUs times 100. So 73.43% is shared by top 10 SKUs. That means 20% of SKUs share 73% profits. So let's see the solution spreadsheet in which it will be easily explained here. Oh, this one is revenue. Here we have the percentage, profit percentage. So what percent of the total profit does the top 20% of the 50 SKUs contribute? So pretty much the same way, what we need to do is we need to see our weekly profit. You need to sort it down in descending order so that you can see the highest earner at the top and the least at the bottom. And then we can easily just select the top 10. That will be top 20% SKUs. And then divide by the total profit. That will be the solution, 73.43%. Now we need to use the same methodology for the bottom 50% of the SKUs. We again go back to our spreadsheet. So for bottom 50%, that's starting from cell number 27. Here, from cell number 27. So it's pretty much the same way. So bottom 50% of SKUs will be equal to this, and we already know the total, so it will be equal to 50% divided by total times 100, so that will be 4%. And if we go back to our solutions, so here we did pretty much the same thing. Oh, I think I selected a wrong tab over there. One second, let me correct that one. So weekly profit. So bottom 25. So you can see the sum. Okay, so we have a little problem here. It's selected by mistake. So the sum will be here to here. Okay, so there we go. So 7% profit is shared by the. Sorry, I selected a wrong column while doing my calculations. So there we go. So if we go to the solution, here it is. So what percent of total profit does the bottom 50% of the 50 SKUs contribute per profitability? So here we have 7%. So if you see here, the top 20% share 73% profit, whereas bottom 50% share just 7% profit. So that's how we do classification. Again, this organization should put more focus on these top 20% of SKU units which produce 73% profit, and they should also make some strategy to work on these remaining SKUs to either make it profitable or just discontinue their production because they're not profitable at all. So this is up to the organization which strategy they want to use. Either they want to phase out these products or they want to continue using them and make some strategy in a way so that they can make more profit out of these spare parts. Sometimes these spare parts would be very minor parts which don't have much margin, so they don't share much profit. So it depends what kind of thing you're looking at. Okay, do you have any problems so far? Do you have any problems so far? Can you please type any question as a session? Because I'm not sure if you can hear me perfectly, because I forgot to use this showcase function of the Google Hangout. That's why I can't see you guys. So do you have any problems so far? Shall I go ahead? Can you please put a comment in the question answer tab? And we'll start with our next question, which is question number 1.8. It says, you believe that the fast-moving, high volatile SKUs should be managed separately from the more time spent on improving, with more time spent on improving the forecasting capabilities. You select the criteria for fast-moving to be selling 50 or more per week, and criteria for highly volatile as its coefficient variation greater than or equal to 0.50. So here we need to find the percentage of total profit contributed by fast-moving and highly volatile SKUs. So they are given the condition. So we're going to consider fast-moving as those having sales greater than 50, and highly volatile to be those having coefficient of variation greater than 50. So this is pretty straightforward. We'll just use the same spreadsheet. And here we go. So we need to consider average weekly sales, and we need to consider coefficient of variation, right? So fast moving will be those having sales greater than or equal to 50. So the best way to do is sort these functions in descending order so that you can easily do it. So what we need to do is, so here the criteria is fast moving products, fast moving SKUs are those having average weekly sales greater than or equal to 50. So we can color those in some different colors. So if you see here, this one is 50. So V826 is a fast moving product. And this one is 60, is fast moving product too. The same way, all these products, all these stock keeping units are fast moving because they have average weekly sales greater than or equal to 50. But there is one more criteria which has to be satisfied before we jump over to our solution. So they say they should be volatile too. So for a thing to be volatile, the CB dimension is greater than 50. So we can sort these SKUs basis coefficient of variation in descending order so that we can color. We can color only those which are greater than 50, right? 0.50. So these are the ones. So we see here all stock keeping units from 19 to 2 are actually highly volatile. But we need to see those which are volatile as well as fast moving. That means we are going to color only those in different colors. Let's assume blue this time, which are fast moving as well, because we need to consider both conditions at the same time. So these 4 SKUs are actually fast moving as well as high volatile. So SKU UU885, KK558, K261, DD914 are fast moving and highly volatile. And then we need to find the percentage of profit shared by these SKUs. So let's remove these 2 columns to avoid confusion. So percentage, the total profit shared by these 4 SKUs. 4 SKUs, so just write like that. So that will be equal to sum of this, then we have, one second, this, and we have this. So that's the total profit shared by these 4 SKUs, and the total profit will be equal to sum of all. Oh, I'm so sorry about this thing because we need to consider average weekly profit. So to avoid confusion, I'm sorry about that. Wait up. So we will just hide these columns so that there is no confusion at all. So sum will be this, and this. And total will be sum of all. So now we see here the percent profit share by these is this divided by total times 100. So we got 32%. And we go back to our solutions. %, here. So what we did is very easy. First, you sort everything. Oh, can you see this? Yeah, you can. So first, you need to sort all these things. First, average weekly sales, so you can see which all stock keeping units are greater than or equal to 50. Then you sort everything as per coefficient of variations, and then you will see the solution. Everything becomes easy and clear. So you can color differently your SKU IDs, which are both fast moving, which are more than 50 average weekly sales, and highly volatile, more than 0.50 coefficient of variation. And then you can see the profit, average weekly profit shared by these 4 items divided by total profit times 100. That will be your solution. So that's 32%. So 32% profit is shared by highly volatile and fast moving SKUs. So these are the SKUs which need to be managed properly. All right. So that's the end of first question. Now we'll move to our second set of questions. Now if you see here, our second set of questions are uncertainty at dog company. So this is pretty straightforward again. So you have joined the supply chain group at a company, and what you have seen, the boss over there, he has his own rules, and just to be safe, he keeps adding 10% on top of everything to manage his inventory and supply and demand. But what you discover is he's not right all the time, but since he's your boss, you can't be mean to him and can't say anything straightforward. So what you decided, you started calculating stuff on different papers and then presented him the solution. So we have here, you identify two SKUs that have common average weekly demand but very different standard deviation. So here we have SKU, which costs $5.95, which is Wilson Chew toys, and you sell them at $9.9. The weekly demand is distributed normally with a mean of 625 and a standard deviation of 225. So this is pretty straightforward data, and the next data given is Dexter Delight Dog Treats. The weekly demand for this one is 630 units and standard deviation is 50 units. If you stock exactly the mean of the demand for any one of the items, that is 625 Wilson Chew toys or 630 of Dexter Delights, what's the probability that your demand will exceed what you have in stock for that item? Okay, so what's happening here? You are keeping exactly mean of the demand for these items. That means you're keeping 625 Wilson Chew toys and 630 Dexter Delight toys. So this question, if you see here, they're saying is normally distributed. That means our K, to find probability of everything, the first thing you should know is you need to know what is K, right? So value of K is actually X minus mean upon standard deviation. And here we are keeping X equal to mean. That means the value of K will become 0, right? So the moment the value of K becomes 0, everything becomes pretty straightforward then. So we need to find, so if you see here, I've written the solution here. So here our K is X minus mean upon standard deviation. This person is keeping X equal to mean for both toys as well as dog treats. So for both stock keeping units, the value X is equal to mean. That means K is 0 in both cases. So if you see your unit normal table distribution, so if you see here for K equals 0, probability is 0.50. So what that means is, if you go back to the question, so what that means is, so if you are stocking exactly mean, then the chances of stocking out are 50%. That means the chances our demand will be met is 50%. The chances our demand will not meet is also 50%. So you just need to find the value of K and the things will become clear. Because here K is 0, from your unit normal distribution table, you can find the probability corresponding to this value of K. I hope that this thing is clearly understood, because this question is very, very important. So is it clear? Is this one clear? Varun, Paul, and Lucas? Is this question clear? You can please type over there, or if you want, I can bring on the answer sheet again. Is this question clear to you so far? Please type in the same question answer comment box. Can you hear me? And we'll move to the next question so you can also watch and recording if you can hear it. So there we go, the next question. Okay, so 2.2. So here we have, using the same two SKUs, you want to see how Hank's rule applies to each of the product and how it impacts the probability of stocking out. So what is the probability that the weekly demand for toys will exceed the level set by Hank's rule? So what Hank is doing here is setting his inventory level at 688, exactly 10% more, right? So he has set his weekly demand at 688. That means our X has become 688. The remaining parameters for that question stays the same. That means here, for toys, our mean is 625 and standard deviation is 225. So this is pretty much the same question. So we need to find K, that is X minus mean upon standard deviation. So this is how you do it. I'll pull out the table here. So here, in this question, X is given to be 638, mean is 625, standard deviation is 225, so K can be calculated easily. That means 638 minus 625 divided by 225, that is equal to 0.28. And corresponding to 0.28, you can see the probability is 0.61. So this is the probability that your demand will meet. But the demand will exceed, that is 1 minus of this probability, that means it is 0.3897. So 39% time you will be stocking out. So this is not a good forecasting as far as Hank's rule is concerned, right? So that's a huge probability that you will be stocking out. I hope this is clear. Now moving to the next question, 2.3. Again, using the same SKU for dog treats, he's setting the inventory level as 693. That means our X now became 693, whereas mean and standard deviation stays the same. So 630 will be the mean and standard deviation will be 50. Again, if we go back to our solutions, you can see how it is solved. So here we have K, which is 693 minus 630 upon 50, that is 1.26. So value probability corresponding to 1.26 is 0.8962. So probability that our demand will meet, that is 0.8962. And probability of stocking out will be 1 minus 0.8962, that is 0.10. That means 10%. There is probability of 10% that demand will not meet or you will go stock out. Okay, I hope that's clear now. So now if we go back to next question, 2.4. So you're giving this data to your manager and he's starting to believe you, but then he applies a different rule to slow moving items. So that's called Hank's slow mover rule. So this rule says that if average weekly demand is less than 10, then stock the average plus 1. You pick 2 slow-moving items for a test now. So you pull out dog bed and you pull out chewables. So for first part dog bed, you see it is following Poisson distribution with a mean of 3 units. That means with lambda of 3 units. And chewables, the weekly demand is also Poisson distribution with a lambda of 6 units. All right. So what is the probability that your demand for beds will exceed the level set by Hank of 4 units? So here you're taking, so using your Poisson distribution tables, what you need to do is, first you need to see the lambda 3. This is for Griffin beds where lambda is 3. So you should use the column where lambda is 3, and then you need to see the value of f of x of 4. So corresponding to that, you can see what was the probability. First, probability that your demand will meet, and what's the probability of stocking out. Okay, so this is pretty straightforward. Just using the graph, just using the table, you can answer this one. Let's go to solutions. Here we go. So here, Griffin beds, lambda is 3, and we have x equal to 4 units, right? So with lambda of 3, this column you have to see corresponding to 4, that is 0.815. So that's the probability that your demand will meet. The probability of stocking out will be 1 minus 0.815. That will be 0.184. So 18% of time you will be stocking out. Okay, so that's how you do this one. Now we go back to the next question. Moving a bit faster because these questions are pretty straightforward. I hope you will understand all these things. If you don't, please stop me anytime. So here again, this is similar to question 2.4. What is the probability that a demand for chewables will exceed the level set by Hank of 7 units? So here lambda is given to be 6, whereas x is given to be 7. So how to do this one? Again, we will be using Poisson distribution tables. And if you see here for the solutions, we have lambda 6 units and x 7 units, Poisson distribution table for value corresponding to lambda 6 and 7. Here we find probability of that our demand will meet the condition set by that particular SKU with 0.74398. So stocking out will be 1 minus 0.74, that is 0.25. So 25% of the times you'll be stocking out if you're following Hank's slow moving rule. Okay? Oh, sorry about that. 1 second. Okay, let's move to the next question now. So we have 2.6. So even after presenting your analysis, Hank is hesitant to change his rules. Well, what should you do? You cannot quit. You need to earn money. Suggest Hank to take CTL.SC1x. No, he's the manager. Maybe he's already aware of these things, but he doesn't want to use. Create a presentation that demonstrates how the lost sales and extra inventory cost impacts Hank's bonus. You should never do that to your boss. You should never make him realize that he's losing bonus and in turn can make him happy. Now, create a presentation that will be the best. Just create a presentation, send an email to your boss, and he'll be more than happy. Okay, so I think we ended with our decided problems for today. So please let me know if you have any doubts. If you have any doubts so far, you can type in question answers. So I think Varun, you had doubts in question 2.2 and 2.5. So let's go back to question 2.2 and 2.5. Let me see if I have answered you. 2.2, yeah, we answered. 2.5, yes, we answered. So how these questions are clear to you, Varun? Are these questions clear to you now? Please type in the question answer application here. And the video will be recorded automatically. You can always see you over there. So please let me know if you're fine with it. Shall I end the session for today? I'm thinking of arranging a practice problem session for week 2 before the due date of next week 2 graded assignment. So you can please type in your question answer. Okay, that's great, Varun. Thanks for typing question and thanks for typing comment here. If you have any other comment, you can please type it now here. If you need to understand some other question from week 1, please let me know. If everything is fine, I can just end this session now. Shall I end the session now, guys? All right, if there is no question, we'll end this session now. Thanks for coming. Take care. And if you have any problem, please use discussion board of edX.org. Okay, that's great, everyone. Thanks. All right, thank you. Have a great day, all of you. Bye. Take care.